All right. Law of sines was what we did already for the past two sections. Now we're on to law of cosines. It's just as easy. Okay. Again, it's just a formula. Okay. So you'll do law of cosine and then switch back to law of sines. It's just that this is a case where you don't have the information that you need to do law of sines initially. Okay. In any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining side. Y'all remember that? In order for it to be a triangle, the two sides must always be greater than one. That's the triangle inequality. Okay. So for example, we're not going to write this down. I know you don't write it down. Okay. Notice here that in this case, what that means is that just pure measurements, their slopes, which is your ratio for sine, cosine, or have to be a certain value. And you just keep going and going, and someone recognizes the pattern like, man, that's crazy. What can we learn from here? Well, what we've learned is law of cosines. Okay. Your law of cosine is useful when you're given, this is what you're writing, the law of cosines. When you're given the sides and no angle. Does that make sense? This is our SSS situation. If I'm looking for an angle, that means I'm going to be using what cosine? Inverse. Inverse. If I'm looking for an angle, I got to use the inverse.
Yes.
Okay. I gave you all three different variations just so that you don't have to think about it. But the main variation is the first one. It's just the angle that you're looking for. The angle that you're looking for in its opposite side. That's the main one. The angle that I'm looking for in its side. Okay. It is always going to be plus the other two sides. I'm so tired. All right. Oh, we're all done? I'm sorry. If you can't see it, remember it's posted on your handy dandy bright space. It's at the very bottom. Okay. All right. If C equals 90 degrees, the third form of the law of cosines, then cosine of C is going to equal 0, right? Because at 90 degrees, what's the cosine? 0. Then that's because of the Pythagorean theorem, a squared plus b squared and all that stuff. So just keep that in mind. All right. We're going to start with the word problem. We're going to get the word problem out the way. You're not. Just draw the triangle. Just draw the triangle. A surveyor wishes to find the distance between two inaccessible points, A and B, on opposite sides of a lake. While standing at point C, she finds that B equals 259 meters and A equals 423 meters. And angle ACB measures 132 degrees and 40 minutes. Find distance C. Yeah. So your triangle is this obtuse triangle like this. You have A, C, B. We know that at B is 259, and we know that A is 423. That's the degree, not the distance. We got to find the distance. It wants to know across the water, how far is A and B? Does that make sense? All right, so looking at your three variations of cosine, which one are we going to use? The C squared, because we're looking for C. Does that make sense? So we're using C squared equals A squared plus B squared minus 2 cosine C. Yes? We're going to identify and just plug everything in. Okay? This is not a right triangle.
Duh. I was testing you.
You were testing me? I knew it. I knew it all along. Did I pass?
Yes, you did.
It's right there.
No, I need you to go back.
The picture's right there.
Okay, good. Yeah. I'm trying to get my angle.
It's right there. All right, so we're gonna plug everything in. So we plug in our A, our B, our A and our B, and our angle C. So I'm gonna go to my handy dandy calculadora.
There's no angle C. Okay, so would that not just be angle C? Like I'm so confused.
You're looking for side C, ma'am.
That's what I don't know what she's talking about.
We're looking for side C.
You're saying angle.
Side C. Yes.
So why is it?
Because it's a typo.
Okay. So that's supposed to be -2?
What equals that were y'all talking about? I don't know. I think y'all were just tripping out here. I don't know what y'all are talking about. All right. Yes. Sorry. So in the calculator, you're literally going to put in, don't even try to simplify before. Let the calculator do the simplification. 423 squared plus 259 squared minus 2 times 423 times 259. And then cosine of 132 plus 40 out of 60. You're going to get a gigantic number. And you're going to then, you want C and it's C squared. So I have to do what? I have to take the square root. So I'm going to take the square root of this value to get that, because it's C squared and you just need the value of C. The formula is C squared. So in order to get C by itself, what do I need to do? You got to take this. We're going to have to take the square root of both sides. All right. To take the square root, I'm just going to go up and grab it. Notice how arrow up, hit enter. And now it places it underneath the square root, and I'm going to get my value. So we got 628. So from point A to point B, it's approximately 628 meters across the pond. Does that make sense? Is your calculator degree mode? You sure? Okay.
You said you do the inverse. You do that for every equation.
You're only going to do the inverse when you need the C. We're given angle C already.
So
we were solving for side C. Any equation that you're solving for the angle, you have to use the inverse. We're not solving for the angle. We were solving for the C, the distance. Okay. So far, law of cosines, chilling. Okay. Whatever. Okay. All right. And then we take the square root. Now, this is when you're looking for the side. I repeat, we found a side. Okay. Oh, I wanted you to do the next one on your own. But it, yeah. But it showed you what to type in, and I don't know how to make it stop.
Another word problem?
No, it's just a triangle. Just want to make sure you can do it. Oh, that highlights it. I thought I was going to hide it. I didn't want you to see the answer. It is not hiding it. It just keeps highlighting.
Stop doing that. Get your own calculator.
I do. I'm trying to see what you got in your.
I don't have anything different.
And you do.
It's not working out. So
So what? We're trying to find angles, basically. Yeah.
yes. And you're finding everything. At least find A. Okay. You big crybabies. Oh, because I chose highlight.
There you go.
That makes sense. I chose highlight. You didn't see nothing.
Anyway, can you go back? What? The flower.
I was like, it's in your face. All right, so at least I want everyone to find A, and then we're gonna go from there. So find my A, and then we'll go from there. Because once we have A, then what can we use? To solve for the rest of the triangle.
Okay.
The law of sines. So we need to find our A.
Did somebody get 109?
I didn't get that.
I don't think I got the high. Yeah. Dang. What'd you do? Let's see. You gotta take the square root, girl.
I'm just saying.
Oh, I thought you were saving for my final answer.
So, you so
Mhm.
50.4.
Squared, I'll bring the square on there.
Right, okay, -2. Did you put 42.3?
No, it's -2 times 12.9 times 15. Yeah, but it's multiply, then the cosine of that.
Multiply.
Yeah, look, it's A times C. You see it?
C.
Oh, sorry, B squared plus C squared minus
Oh, okay.
2 times C cosine of A.
Oh, okay, multiply these two, put the.
And then put the cosine. Yeah. Got it? And you gotta do what with that 109? There we go.
So we gotta find
We're finding everything. But I wanted to make sure we all had A at least, because after that, it just goes back to law of sine,
Right.
right? And y'all professional law of signers, so not worried about that. All right, for your A, did you get 42.3? I mean, not 42.3, meant using 42.3? Yes, okay. You take the square root, you meant?
I mean, yeah.
Yes, your numbers are right. She just wants to keep saying inverse, but she said the right number. You said the right number. Yes. All right. Now, once I have this, all I have to do from here on out is what? Law of sines. So once I have this, my opposite sides, I can set up my ratio for law of sines. Make sense?
Is it, so it's still the inverse of sine?
It's gonna be inverse of sine.
Wait, so what do we do after finding 10.47?
Now we can do law of sines to find our angle C and angle B. You gotta find angle C and angle B. So setting up our signs, right? Because we now know our ratio for A. And now we're gonna use that to solve for B. Which doesn't.
Do we, run the? Yeah.
I had this on here and I was trying to pull up.
Oh, the other problem.
Well, yeah, that's why getting confused.
Because we're on example 2, and you still refer back to example 1.
Oh, we don't know what we're example.
Yeah.
Oh. I thought we were on the same part.
No, we're on example 2. No, I don't know where you went. What y'all get?
For what?
That's big.
Yeah.
55.
Oh.
That's it.
Okay, exactly.
Did I get 55 from me? Yeah. Okay, you.
Cross multiply,
You do something.
divide,
Okay.
do
Inverse.
inverse. You've been wanting to do inverse for a while now, Lupe. Here, time to shine. Inverse sign? Yes.
Sorry.
You got it now? There you go. And then how do you find C now that you have A and B, guys?
Oh, you just
Oh, what
subtract.
age you wanna do?
Oh my god, I started doing like whole process again.
Like, what are y'all doing?
Cause I did the other way.
Cause I just got 80.
Oh,
You're trying to the nearest measure.
Okay,
I just
when
did
you're the rule of thumb for doing this is you're gonna always do it for the smaller size of the two. Does that make sense?
Oh,
So you start with the smaller one. So B was our smaller side, right? So you use log sign for that. That avoids you making sure that it's not an obtuse angle. Because it can be obtuse because it's not the biggest.
so we're using 56 instead of 55.8.
I mean, I did just for the sake of ease.
Gotcha.
But you can do, if you did decimals, it's perfectly fine. And then how do we find C?
A minus, A plus B minus B.
What we get 10 for,
That's our A, that's our A.
That's our A, is what we solved. So the very first thing we found, while you were doing whatever you were doing, is what we found. That's what we found on example 2. If you look right here,
I don't know.
so we use A squared equals B squared plus C squared, right? We plug in all the information that we knew. And then we plug that in, and we get the square root, and that's how we end up with 10.47.
Y'all, it's a lot, but at least it's not like, you know.
It's not terrible, right?
Okay, I'm not for algebra any day. Okay.
I would too, not gonna lie. I like it, you know, I just didn't like this.
Yeah,
So,
for angle C,
Uh,
I know how, like, I know you do subtracting and all
Yeah.
that, but how do you know what number you're using? Like, to subtract? Like,
A and B.
is that all the time?
Angle A, the
Like,
two
all-
angles that you know, you're gonna subtract to find the one you know.
I'm just making sure, you know.
Okay,
Just making
I love it. All right, to know which one you're gonna do law of signs with, it's always the smaller one of the side, okay? You're looking for which one is your smallest, okay?
Out of the angle?
Out of the sides, the unknowns. So when we were here, we knew that this was 10.47. Out of the two that we have to solve for with signs, you're gonna choose the smallest. So we're gonna solve for angle
Put in the denominator?
to do the ratio. Does that make sense?
Yeah.
Out of the two things the two unknown angles, you're gonna look at their sides, and the one with the smaller side is the one that you're gonna use law of signs with. Okay. That's because the possibility of getting an obtuse, you avoid it if you're using the smaller one to guarantee that it's not. All right. See, ready? Had we used the law of signs to find C rather than B, we would not have known either C was equal to A1.C or supplement. So to avoid that, we always use the smaller. Got it?
Oh, damn.
All right, are y'all ready to try it without an angle? So now Lupe gets to shine again using what? Inverse. Okay. So we have our triangle, but we have no angle. Side, side, side.
How does one do that?
We're gonna go through it. We have just a triangle with all its sides. So we have triangle A, B, C, and we know that A is 9.47. We know that B is 15.9, and we know that C is 21.1. Okay. Of this, what is our biggest angle? Our biggest side is C, so therefore our biggest angle is gonna be angle C. Does that make sense? Okay, because it's our biggest side, we're gonna start looking for C first. Make sense? So we're gonna be
You don't
using,
have the angle, you go for the what?
exactly, we go for the biggest. So we're gonna do C squared equals A squared plus B squared minus 2AB cosine C. And we're gonna plug in what we know, which is all of our sides, right? We're gonna plug in all of our sides. Is this a good pace? Or am I going too fast? So we plug in all our sides, but what you need to do is you're gonna need to isolate your cosine. So you have a choice here to plug in and isolate or isolate then plug in. Doesn't matter which way you do. Okay, so whether you choose to plug in then isolate, cool, or isolate then plug in is 100% up to you. Okay, by isolating, notice here, I need to get angle C by itself. In order to get by itself, I have to subtract. Does that make sense? So you have a couple choices here. I don't really care which one you choose to do. It's up to you.
Okay, so for C, since we don't have, wait, we have C.
Yeah, we have all the sides. Yes.
Can you explain the process how it got down to that?
Yes, I surely can. So the first thing I did was I added 2ab cosine C to this side. So I have now C squared plus 2ab cosine of C equals A squared plus B squared. My goal is to get cosine C by itself. So the first thing I'm going to do is subtract C squared, correct? So when I subtract C squared, I'm left with 2ab cosine of C equals A squared plus B squared minus C squared. The last thing I need to do is divide to get rid of 2ab. So I divided both sides by 2ab, and now cosine C is by itself. Can you still do that with the numbers in place? Yes.
So is cosine C like 403? I just did that whole thing, like, just trying to-
You messed up somewhere.
Shut the hell.
I'm looking at the answer and that's not right.
Cause I did it like, I did do something wrong. I tried to just put it in, yeah, and I just put everything in and I just put it.
Okay, so let's go over if you try to do it without isolating beforehand. Okay,
I got 61. I don't think that's right.
all right. So if you're trying to isolate before without, that means you're starting at this point, right? Yes.
Oh, wait.
Yes. Okay.
I didn't figure out if I was like playing.
Okay. Well, I'm gonna go, but you can.
This is if you don't isolate.
This is if you don't isolate. So if you're not isolating, you're plugging in what you know. What is C squared? 21.1. So we have 21.1 squared. Okay. We need to start moving things away from cosine. So the first thing you're going to do is subtract your A squared minus your A squared, which is 9.47 squared. Then you need to subtract your B squared because you're doing all opposite behaviors, correct? So I'm going to subtract my B squared, which is 15.9 squared. Okay, there's nothing left for me to add or subtract. Now it comes down to dividing. Because everything has been now subtracted. So now I'm going to have to divide by negative 2ab. So then I'm going to divide by negative 2 times a, which is 9.47. I'm working backwards to get it by itself, right? A, which is 9.47 times B, which is 15.9. And now everything is in. I'm going to hit enter. And it's going to tell me negative 0.341. Okay, that's if you want to plug it, if you want to plug in your numbers first and work your way backwards. Now you're going to take the inverse. So I'm going to do cosine inverse of what I got here. So I arrow up, hit enter, and I'm going to get my angle is square.
That's a lot more work. Not do that.
So like I said, you have the choice to plug in and isolate or isolate then plug in. Doesn't matter which one you choose to do. Okay, so we end up that angle C is 109.938. So we're just gonna call it what? 109.9. Is that cool? We're gonna do 109.9. And now I have this. So from here on out, once I've done law of cosine, what can I do from now? Law of sines. Make sense? It says solve the triangle. It does. So we have 109.9 degrees. Okay. Which angle am I going to solve for first? And why is that? Y'all are so smart. Wait.
Oh.
Why did it have us solve? I always solve for the smaller one.
That's okay, let's just keep going.
Oh, it doesn't matter because we don't have to worry about it being obtuse. Because we already have our obtuse angle.
We already have it.
Yeah, it doesn't matter. You can do whichever one you want. Because we already have our obtuse angle. I was like, wait, why did it not do that? Okay, so I'm going to solve for B.
I don't want to get a decimal.
Because,
Okay, because we need it.
yeah. Forgot, we knew our obtuse angle already. So we don't have to worry about which side we do. And then once you know two angles, what do? You just add and subtract. And you find your final answer. So we've now solved for all three angles. So we know that angle C equals 109.9 degrees. Angle B equals 45.1 degrees. And angle A equals 25 degrees. Is law of cosine doable? Yes. All right, there's one formula left that we have to add to our repertoire. I know. I was getting that. All right. Do we need more practice or we felt good about it? All right. There is a summary chart of just kind of the general steps if you want to go back to it. Okay. Our last formula. It's called Herons area formula. Herons area formula. Okay. It's a way to find the area of a triangle if all you have are the sides. Okay. If all you have is SSS.
Is that what semi-perimeter?
It's called semi-perimeter. It's the value. It's when you have all sides. Okay. Herons area formula works if you do not know any angles or any other measurements or your height or anything to find the area of that triangle.
The S.
It's a two-part, yeah, it's a two-part formula. You have to find S first, and then once you have S, you then are gonna,
Oh, S is semi.
yeah, S is your semi-perimeter. And once you find S, you then are gonna plug that value along with the sides into the area formula. And this is our last little piece for our unit 7. I don't know why you do that to yourself, America.
Because I can't miss anything.
Fine.
What does S mean?
S is called your semi-perimeter. It's right here.
You have all sides.
You add up all the sides and cut it in half. That's why it's a semi-perimeter. Oh, thank you.
Okay.
Oh, okay.
I'm talking about the S and the area.
Thank you so much. The S comes from here. You have to find this part first. And then you'll plug it in wherever there's an S. Okay?
So what do we plug in for A, B, and C?
Those are your sides.
Okay.
Those are your given sides. So for example, it says right here, it's a, what are you doing? So for example, here you have Montreal, New York, and Los Angeles and how far apart they are from each other, right? And I want to know what's the area of these cities combined, like the area that the mass. Okay, I'm gonna first find my S.
Angles, right? Can't I just 180 minus da 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 da?
We're not doing angles, it's area.
I thought area was 1/2 based on size.
That's
Oh,
if
you
you
don't
have a
know that.
height. Ah, we don't have angles, we can't find our height, all these things when we can't do, someone's like, well, here you can, okay? So up first, you gotta find your S. So you find your S first by plugging in your size that you know and cut them in half. Once you find your S, once you find your S, you then are plugging in the S everywhere in the formula that it goes and plugging in your values. And then when you're done, you put in the calculator and you get the area that it's covered. And that's it. That's the last of it.
Oh, that's pretty.
Of 7.3.
And that's the one, that's the last one?
This is it for 7.3. So we're done.
I'm gonna go home. I'm not gonna go home.